Hello, today our group will presenting about our technical report KNS1102 Engineering Geology site visit trip to Jabatan Mineral dan Geoscience Malaysia. I'm glad you could have take the time to be here. I hope you find these sessions informative and engaging. Feel free to take notes and reach out with any questions or comment you might have. Okay, let's go. Before we start, I would like to introduce my group members. My group consists of 5 members, with each my name, Anderson, Edmund Didi, Eric Jong, Fabian, and Muhammad Amizi. Igneous rock can be classified into two different groups, which is plutonic and volcanic. Igneous rock formed from magma or lava solidifications. From our visit trips, we investigate quartz gabbro is type of plutonic igneous rock that has been found at Bukit Kunang Lubuk Antu district. Quartz gabbro is a dark gray to black color, with texture is phenolitic, which is medium to coarse grain. Gabbro is a dense rock with a specific gravity higher than that of granite, making it heavier in hand. Gabbro formed through the process of solidification of magma at relatively deep level within the earth crust or upper mantle. The second one is volcanic type rock. We found out that basalt was in their group, which is found at Bukit Pesai Lubuk Antu. Basalt also have the same color with gabbro, which is dark gray to black with hardness 5 to 6 more scale. Basalt forms from the rapid cooling of lava at the Earth's surface. Next, sedimentary rock can be also classified into two different classes, which is clastic and non-clastic rock. We found out breccia is the clastic rock groups. Breccia is a fascinating clastic sedimentary rocks formed from angular fragments or of other rocks cemented together. The angular fragments are held together by cement, which can be calcite, silica, or other minerals. Breccia form in various environments including fault zones, riverbed, and glacier deposit. Bauxite can be classified in this group, which is non-clastic group, which can be found at Sematang, Sarawak. Physical properties of bauxite. The common color of bauxite is brown, with streak usually white, but iron stain can be discolored. With hardness 1 to 3 more hardness and specific gravity 2.2 to 2.5. Bauxite is formed through a weathering process that occurs in tropical and subtropical regions in high rainfall. In conclusions, sedimentary rock formed from sediment compactions. Next, metamorphic rock. Metamorphic rock also can be classified into two different classes. It is regional metamorphic rocks and contact metamorphic rock. Metamorphic rock forms by formations of other rocks. Also, metamorphic rocks is a relative hard and may or not made to have the layers. For regional metamorphic rocks, the rock example is slate. Slate can be identified at Lundu district. Physical properties of slate is the color is black, blue, greens, red, or browns. The texture is foliated metamorphic rocks and foliations on scale. The grain size is very grain, not visible for the naked eyes. The hardness is very hard and brittle. Slate is deposited in sedimentary basins where finer particles transported by wind or water. Next, cut silicate for contact metamorphic rock. Cut silicate can be identified at Lucky Hill Mine, Bau district. Physical properties of silicate is the color is variable, generally gray to black. The texture is very granular, pretty or elongate crystal randomly oriented, so no fluorescence evidence. The grain size is very fine grained the hardness is very hard. Cut-silicate forms by metamorphisms of impure limestone or dolostone related to skarn. Mineral can be classified into three different groups, which is metallic, non-metallic, and precious mineral. The first one is metallic mineral that contain metal element in their chemical composition. The rock example is stibnite that can be identified as jambusan bau. Physical properties of stibnite is relatively soft with more hardness is about 2.0 with density range from 4.5 to 4.7 gram per centimeter cubic. Stibnite exhibit perfect cleavage in one direction, meaning it can be easily split into tin. Stibnite has a metallic luster and shiny. The color of stibnite is usually gray. The second one is non-metallic. Non-metallic is a mineral that do not contain metal element. The example of rock is quartz crystal that can be found at Pangkalan Tebang Bau. The color of quartz crystal is clear, white, gray, brown, and black. Which strike is colorless, no luster in on metallic minerals. Cleavage is none, and hardness is about 7 more hardness and specific gravity 2.6 to 2.7 gram per centimeter cubic. Precious mineral is a mineral that consists of both metallic and non-metallic mineral. The example is gold that can be found at Bau district. The color is rich yellow with shining yellow. Luster is metallic, cleavage non-observed, with hardness 2.5 to 3.5 more hardness, and density is about 15 to 19.0 gram per centimeter cubic. Macrofossil in metamorphic rock might include imprint of mineralized remains of larger organisms such as plants, shell, or bones. These fossils can be highly deformed or recrystallized due to metamorphic processes. As you can see, this is a recently snail can be classified as a microfossils enough to be seen without a microscope. Next, microfossil require a microscope to be seen observed. They include tiny remains of plants, bacteria, and animals. Each are essentials for understanding the history of microscopic life and in ancient environmental conditions. Next, trace fossils. Trace fossils are indirect evidence of ancient life representing the activities of organisms rather than their physical remains. This is a group of Penolite is around the age around 350 to 300 million years ago that can be identified at Pulau Ural Langkawi.
In this part, I will explain about the rock identification of three types of rock, which is igneous, sedimentary, and metamorphic. For the first one is igneous, which is a big andesite. The rock identification is the color is light to dark gray, bluish gray, or reddish. The appearance is andesite. Andesite typically appears sparkle due to its mineral composition. It has a fine-grained texture, meaning its interlock crystal cannot to be seen by the naked eye. The composition of the rock. The site is primarily composed of plagial clays, feldspar, and significant amount of mafic mineral like hornblende. It falls between granite, high silica, and basalt low silica in terms of mineral content. For the characteristic features and physical properties, the hardness and density. The site is a hard rock with a more hardness of 7, and its density range from 2.6 to 2.8 gram per cubic centimeter. The silica for the silica content for this rock is andesite fall into the intermediate category in terms of silica content and is contain less than 20% quartz and 10% Zoid by volume. Mode of formation and occurrence. The site Iram from volcano and is often found interbedded with volcano ash and tuff. Ancient site help map subductive zone because they fall above this zone and continental or oceanic crush. The similar rock to the site is the site. The site is another extrusive igneous rock that shares similar with andesite in composition. Rock identification for coal. The color for coal is ranged from black to brown to grayish. There are three types of coal, which is bituminous coal, arctic coal, and lignite. The characteristic features and physical properties of the coal is hardness and density. The hardness is the more hardness is 1 to 4, and the density is very soft, which like graphite, and to very hard, like arsite. The composition. The main element in coal is carbon. It can contain other elements such as hydrogen, sulfur, and oxygen. Unlike minerals, coal lack a fixed chemical composition and crystal structure. For mode of formation and occurrence, core form from the decay of dead plant matter and over millions of years. Initially, this organic material accumulates as peat in wetland. With deep burial and pressure, peat transforms into coal seams within rock layer. The similar rock is graphite. Graphite is a form of carbon, just like coal. It's soft, black, and shiny mineral. Unlike coal, graphite is not a sedimentary rock. It is a metamorphic mineral. Graphite is used in pencil, lubricant, and as a conductor in battery. The last one is marble. The rock identification for marble is the color is white, pink, gray, and another various color. The appearance for the marble is crystalline. The grain size is it has a medium grain texture, allow you to see interlocked calcite crystal with the naked eye. The characteristic features and physical properties. The marble has the more hardness of 3, making marble hard. The structure is appear massive and granoblastic, and the composite is primarily composed of the mineral calcite (CaSO3) and often contain other minerals such as clay mineral, mica's, quartz, pyrites, iron oxide, and graphite. Acid reaction. Being composed of calcium carbonate, marble neutralizes acid effectively. And lastly, ability to accept a polish. After sanding, marble can achieve a high luster, making it ideal for decorative stone, floor and sculpture. Mode of formation and occurrence. The transformation of limestone into marble occur at convergent plates boundary or throughout contact metamorphisms when hot magma hits adjacent limestone or dolostone. The recrystallization process results in interlocked calcite crystal, obscuring the original fossil and sedimentary structure of the limestone. The similest rock to marble is quartz.
Hi guys, I'm Eric Jong Chiasen with Numerics 101668, and I will continue the presentations on mineral identifications. Today we'll be exploring the various properties, formation, and occurrences of these fascinating minerals. First, let's go through an overview of what we'll cover. We will look at the physical and chemical properties of galena, its typical formations and occurrences, and its locality, particularly in the bow area. Galena exhibit a massive cubic and octahedral habit. It has a perfect cubic cleavage in three directions and is characterized by its lead gray color. The luster is metallic and it has a hardness of 2.5 to 2.75 on the Mohs scale. Its specific gravity ranges between 7.4 and 7.6, which is quite high due to its lead content. Galena is a sulfide mineral with the chemical formula PbS. It leaves a dark gray to black streak when scratched on a straight plate, and it has a subconchoidal fracture pattern. Galena can form in a wide range of hydrothermal environments. It is commonly associated with massive sulfide deposits that occur with metavolcanic rocks, such as the Crandon deposit near Rhinelander. Consists of it with ferrite and chalcopyrite. Additionally, it can be found in several pegmatite and granite. One of the significant occurrences of galena is in the low temperature hydrothermal deposit known as Mississippi Valley type deposits. Secondly is the calcite, which has the locality particularly in Bau district. Calcite exhibit the rhombohedral and scalenohedral habits. It has a perfect cleavage in three directions and also colorless or white or has various colors such as red, yellow, green, blue, and purple. The luster of calcite is vitreous to pearly and have the hardness of 3 on more scale. Calcite is a carbonate mineral with the code M459, which have the specific gravity of 2.71. Calcite shows a white streak when being scratched on a straight plate and exhibit conchoidal fracture pattern. Calcite is a mineral that occurs abundantly in many different kinds of geological environments. It is formed by precipitation from ground and surface water and also a major component of marls and limestone in the oceans, lakes, and rivers. It also forms speleothems in cave, euhedral crystal in valves, and tufa where springs emerge on the surface. Thirdly, magnetite is a mineral that exhibits massive and octahedral habits, which locate at Gunung Gual, Simojan district. Magnetite has no cleavage. It may show some parting, which is a break along structural planes and is parallel to a possible face, just like cleavage. Magnetite also characterized by its black or brownish black color. The luster of magnetite is metallic and having the hardness between 5.5 to 6.5 on the Mohs scale. The specific gravity of magnetite is 5.17, and it is also an oxide mineral with black streak when scratched on a straight plate, and it has a subconchoidal fracture. It can be formed due to the situation that a mafic magma cools slowly enough. Dense magnetite crystal may settle while crystallizing, forming massive magnetite ore bodies with a strong magnetic character. Magnetite can also form during the contact metamorphism of impure iron-rich limestone or in high temperature hydrothermal sulfide veins deposit. Fourthly, fluorite exhibits several distinct habits including massive, granular, and cubic forms, and the locality of fluorite is at Peninsular Malaysia. One of its most notable features is its perfect octahedral cleavage in four directions, making it easily identifiable among other minerals. The color of fluorite can vary widely, with common shades including purple, green, and yellow. It also can be found in colors such as blue, red, and black, or even colorless. It has a vitreous or glassy luster, giving it a shiny and attractive appearance. On the Mohs scale of hardness, fluorite has a hardness of 4, making it relatively soft compared to other minerals like quartz. Fluoride's specific gravity is 3.2, which is a measure of its density relative to water. As a halide mineral, fluoride is classified under the code of M103. When rub the fluoride on a streak plate, it leaves a white streak and it has a conchoidal fracture pattern, resulting in smooth, curved surfaces when it breaks. Fluoride typically can be formed through the hydrothermal processes, where hot mineral-rich fluid circulate deep within the Earth's crust. This fluid, which often come from magma or heated groundwater, contain dissolved fluorine along with other elements. Fluid cool gradually as they move through fissures and fractures in existing rocks. Lastly, malachite typically forms in a variety of habits, including massive, botryoidal, stalactitic, and prismatic structures. Malachite's locality is at Chumpahin Mine, Baut District. One of the key characteristics of malachite is its perfect cleavage in one direction, which help in identifying and studying this mineral. The color of malachites range from light to dark green, often exhibiting beautiful bending patterns that enhance its visual appeal. Malachite's luster can vary from vitreous to silky or dull, depending on the specific specimen. On the Mohs scale of hardness, malachite is between 3.5 and 4, making it relatively soft and easy to work with various decorative purposes. The specific gravity of malachite ranges from 3.6 to 4, reflecting its density. As a copper carbonate hydroxide mineral, malachite is classified with the code M354. When it's streaked, malachite leaves a light green mark, and it exhibits a subconchoidal fracture, meaning it breaks with curved surfaces. Malachite is formed while the surface weathering process of copper ore and is generally not used for copper extraction due to insignificant resources and inadequate metallurgical recovery. The crystal system is monoclinic with perfect cleavage and contact or penetration training.
Hello everyone, today I'd like to share some fascinating information about a shark tooth from the Kerkodon species. This particular fossil was discovered off mile 68 Bintulumiri Road and dates back to Miocene epoch, which lasted approximately 23 to 5.3 million years ago. During this time, the environment consisted marine sediments, including sandstones and shells, and ranged from coastals to open ocean settings. These sharks were apex predators with a diverse range of prey. The teeth of these sharks are typically triangular and serrated. Great white shark teeth can measure between 1 to 3 inches, and megalodon teeth can reach up to 6 inches. The color of these fossilized teeth varies due to the mineralizations processes over millions of years. Shark teeth are formed by continuous tooth replacement, and they are commonly found in marine deposits, beach sands, and river gravels. Notable locations where these fossils are often discovered included Maryland, South Carolina, Peru, Chile, and Europe. Now, let's move on to another intriguing fossils, the Phylloceras and Ammonite. These fossils were found along Mile 17 Kuching Serian Road and dates back to a much older period, ranging from the Lower Jurassic to the Lower Cretaceous, approximately 201 to 66 million years ago. The paleo environment during this time included swamplands and shallow seas, where these ammonites thrive. Phylloceras is characterized by a distinctive leaf-like suture patterns on the shells. These aragonite shells were preserved through a process called diagenesis, which transformed them into fossils. Phylloceras fossils are typically found in limestones and shell deposits. Significant locations for finding these fossils include Mediterranean region and North America.
I'm I'm gonna continue the presentation for the last species of fossil that our group did. This species named gastropod species is locality at Sungai Miras Danau Kuching district, and the age is appreciate uh, late Jurassic to the late Cretaceous. The The paleo environment is involved from marine ancestor to freshwater and terrestrial habitats, and it also peaked after an Cretaceous extinction. So the description for the species is muscular foot, eyes, and tentacles. Radula is also called or conical shells. Some species that shellless. For the formation and occurrence, the shells formed by calcium carbonate extrusion. They also found in limestone, sandstone, or shell, and the location is usually can be found in western interior North America or Paris Basin and Florida. Uh, In conclusion, the site visit trip has been informative and has helped presented the geology type of rock such as igneous, sedimentary, and metamorphic rock and other information related to rock forming minerals. Consequently, we have observed the ground rocks and sample to gain insight into the story, structure, and minerals of the area with with a variety of different characteristics such as color, luster, hardness, and other physical features. There were tons of valuable lessons we learned from this site visit to Kuching Department of Geoscience and Minerals and the Museum of Geology. In conclusion, the site visit has significantly enhanced our geological knowledge of Kuching Department and the Museum of Geology. The data collected will support ongoing research and understanding geology. The site visit trip was deeper our understanding of geology areas. Okay. Last but not least, that's all from our group. Thank you.